Today we're talking about calculating molarity. The molarity formula is pretty simple. Molarity is equal to moles of solute over liters of solution. If you're not clear on what solute and solution are, you need to go back to your notes and figure that out. The units of your answer are always going to be a capital M. Does anybody know why you don't want to use a small m? That's right. A small m is for meters, not molarity. Now I said that the formula for molarity was simple, and it is, but there is a catch. Most of the times the problems are going to say that you have a certain number of grams of something and a certain number of milliliters in something. If you look at the formula, it has to be in moles and liters. This means that you have to draw on your past experience and your vast knowledge on how to do mole conversions. If you don't remember how to do those, there are videos available on the course that will help you remember how to do mole conversions, because you'll have to change from grams to moles. And if you don't understand how to do unit conversions of milliliters to liters, there's videos on that as well. Or you can just ask your teacher. So let's do a couple of problems. On this one, we have 37.5 grams of sodium hydroxide dissolved in 500 milliliters of solution. What is the molarity of the solution? Well, as I said before, we're going to have to change the grams of solute into moles of solute. We can do that by taking what we know, 37.5 grams of sodium hydroxide, and we also can figure out how many grams of sodium hydroxide are in 1 mole of sodium hydroxide. All we need to do is consult our trusty periodic table, and we find that sodium has 23 grams per mole, oxygen has 16 grams per mole, and hydrogen has 1 gram per mole, and that all adds up to 40 grams per mole in 1 mole of sodium hydroxide. So all we have to do to convert those grams to moles is take 37.5 grams divided by 40 grams, and we know that that is 0.94 moles of sodium hydroxide. Yay, we're done, right? No, I don't think so. The question was asking us for molarity, not number of moles. Okay, so now we take 0.94 moles divided by 500? No, because 500 is in milliliters and we need it to be in liters. 1 liter is equal to 1,000 milliliters, so 500 milliliters is 0.5 liters. Now we can plug all of our numbers into our formula and take 0.94 moles divided by 0.5 liters, and our answer is going to be 1.88 molarity, capital M. As usual, I am not going to be a stickler for significant figures because we are on a deal where we're just trying to relearn this stuff, so I really just want you to be able to do the calculations. Okay, let's do another. What volume in liters of 4.5 molar HCl will contain 0.25 moles of HCl? Remembering that molarity is equal to moles of solute divided by liters of solution, we know that 4.5 molarity is equal to 0.25 moles divided by the liters of solution, which I've replaced with x because that is our unknown variable. Okay, so I've done algebra on the equation and I've isolated x. X equals 0.25 moles divided by 4.50 molarity. Now, if you aren't following how I got to that, it might actually be easier for you to ask one of your peers to help you with that, or I'm sure that your math teacher would be happy to go over it with you. Once I have my equation with x isolated, it's pretty simple calculation. I just take my 0.25 divided by 4.5, and my answer is going to be 0.06 liters of HCl. And that, my friends, is a simple tutorial on how to do molarity calculations. Now go try some on your own. There are a few molarity problems in the review resources section that I had assigned to you last week to do before the test. So you can go and look at those problems and see if you can calculate them. The answers are also in that file, so you would be able to check to see if you get the right answers. And let me know if you have any questions.